Hello, in this video we are going to continue with the presentation. We are going to see how unconstrained delegation works, but before doing so, we are going to see how our web application is actually configured, the web application that we've been talking about throughout the presentation. So as we can see, the application pool, this is all run in Internet Information Services, IIS. So the application pool is running with the domain account SerBrowser service. Okay, this application is configured with Windows authentication, and also client impersonation is enabled. As we know, the only provider supported right now is Kerberos. And here we can see the actual process that is running this service with the name w3wp.exe, which is the IIS worker process. And we see that the account running this process is SerBrowser service. This account is within the group IIS app pool SerBrowser, and we can see here that this account holds enough privileges to impersonate their clients, his clients. Okay. Finally, we can see that this account is configured the following SPNs so as to support Kerberos authentications: http serbrowser.capsule.corp. So at the end, our application and our clients are working like this. Vegeta authenticates into the application impersonates Vegeta, and this new thread with the access token and potential credentials of Vegeta will try to list the folder, the ser folder that is offered by SQL01. As we know, in order to do that, we need credential material. So we need to ensure that credentials are placed in the logon session associated to this token. So what it is unconstrained delegation? Unconstrained delegation is a feature of Active Directory that forces, or well, not forces, but the idea of this feature is that clients delegate a copy of their TGT to the delegation server. Okay, so when the server needs to act on behalf of any of his clients, it will use those TGTs that will have cached to request further service tickets and to act on behalf of them. In order to set up this delegation, you will require either domain or enterprise admin privileges, because the privilege that you will actually require will be the CA enable delegation, which often is only a domain or enterprise admin privilege. Okay, so we are going to configure our service with unconstrained delegation. In the interface, in the graphical interface, this delegation option is this one: trust this user for delegation to any service, Kerberos only. Okay, and when we configure this setting in a service account, we will see that within its user account control settings, there is this trusted for delegation setting set up. If we try to log in into the application, we will see that now it works. We don't have a access denied error like before. So what's happening under the hood? The first thing that it will happen is Vegeta will ask for a TGT when we specify those credentials in the login page. The first thing that will happen is asking for a TGT. Then the client, Vegeta, will ask for a service ticket for the web application. We know it is the SPN http serbrowser.capsule.corp. Then the client again will ask for a copy of its TGT, a delegation TGT that he will send to the service to be cached in a logon session. Then the client will try to authenticate into the actual service. He will send the service ticket for HTTP, an authenticator, and a delegation TGT. In fact, the delegation TGT will be within the authenticator. Then the service, we can see that this is between .12 and .5. .12 is web01 and .5 is DC01. So we can see that the service that he will try to list the shared folder and that is located in SQL01. The service will require a service ticket for that service. So here we can see how the service asks for this thieves ticket, and we will see that it will use the delegation TGT in order to act on behalf of Vegeta. Once he has the service ticket, he can access the shared folder and list the contents, and then respond the client with all this information and AP response to perform a mutual authentication. So we will see this step by step. First, we know that the client just asks for a TGT, a timestamp encrypted with his secret key will be sent. The domain controller will verify with the secret key of that user if it can decrypt that timestamp, and then will respond with a TGT and an encrypted piece of the AES response. The client will decrypt this encrypted part with his own secret key, and he will be able to extract the session key associated to the TGT. Then the client will ask for a HTTP service ticket in order to use the web application. For doing so, he will create an authenticator. He will encrypt that authenticator with the session key and send the authenticator, the TGT, and the SPN will be HTTP, as we know. So we can see this here. This is the TGT, this is the authenticator, and the target SPN is http serbrowser.capsule.corp. So when the domain controller receives this request, he will verify if the TGT and authenticator information is all right, for example, by confirming that the identity in both is Vegeta, the integrity, because the domain controller can decrypt properly this ticket, etc. And then the domain controller will notice that this, the target SPN, has unconstrained delegation configured. The target server has the trusted for delegation setting. So the domain controller will respond with a service ticket and an encrypted TGS response. The thing with this response is, well, we know the KDC confirms that the service is configured with unconstrained delegation. So the service ticket will result in a service ticket with the OK as delegate flag. Okay. So the client will know that this service is suitable as a delegate because in the encrypted part of the TGS response, he will not only receive the session key, but also flag information of the ticket. And we can see that the OK as delegate flag is true in this case. Okay, so the client, the first thing he does is decrypting this information, taking the session key of the service ticket, and then confirm that this service is suitable as a delegate in the information of the encrypted part of the TGS response. So as a second request, the client will ask for a copy of its own TGT, for a delegation TGT. In order to do that, he will once again create an authenticator with the session key of the TGT, and he will send another TGS request with the authenticator, the TGT, and the KRV TGT SPN in this case. So this is like a follow-up request from the client that the KDC is expecting. Okay, so we can see that this is the TGT, the authenticator, and in this case, the client asks for a forwarded TGT because he wants to send this TGT to the Web01 service. Okay. The target SPN is krvtgt.capsule.corp. The domain controller will confirm everything within the TGT and the authenticator, etc. And then he will see the request of a forwarded TGT. Since the KDC was expecting this request as a follow-up of the previous one, he will know that this copy of TGT will be used for http serverbrowser.capsule.corp. Okay, this is what is explained here, and we can see that the resulting TGT has the expected forwarded flag. At least that is what the encrypted part of the TGS response is saying to us, the client. Forwarded flag is true. We have the session key and we see that the target SPN of this ticket is KRV TGT. Okay, so once the client has all this information, HTTP service ticket and a delegation ticket, well, the first thing that he will do when he receives the TGS response is obviously decrypting and obtaining the session key associated to the TGT, because as we know, TGT alone is not sufficient to ask for service tickets. We always need the session key associated to the ticket we are going to use or we want to use. So the client confirms that this ticket has a forwarded flag by this information, and then when he wants to interact with the actual service, he will create an authenticator with the TGT, a copy of the TGT or the delegation TGT and the associated session key within the authenticator and encrypted with the session key that will be mutual between the Web01 service and the client. So the client just sends the HTTP service ticket and the authenticator with all the information. We can see this here. This is the service ticket pointing to http serverbrowser.capsule.corp, and we see here the authenticator. If we decrypt the authenticator, we can verify that within the checksum structure there is a delegation flag here, delegate credentials to remote peer, and it is enabled, and we can see a KRV credential structure there. Within this structure there is indeed our delegation TGT, and in the encrypted part below we see the session key associated. This session key is encrypted with this other subkey, the encrypted part. You can decrypt it with the subkey below. Okay, so the service then what he will do is, the first thing, decrypting the service ticket because it is encrypted with his secret key. He will extract the session key, and he will decrypt the authenticator with that session key. Within the authenticator there is the delegation TGT of Vegeta and the associated session key. So the service cached these two things. Then when the service aims to list the shared folder that is in SQL01, he will use this delegation TGT to act on behalf of Vegeta and to ask for a Thieves service ticket for SQL01. So the service creates an authenticator, encrypts it with the mutual session key, and sends a TGS request, a regular TGS request on behalf of Vegeta. We can see here the TGT, the authenticator, and the target SPN is Thieves SQL01. The domain controller will verify that everything is correct and will respond with a service ticket for SQL01. We can see that it is encrypted with the secret key of SQL01 and the encrypted TGS response. Just a regular TGS response, but in the name of Vegeta. So the service will decrypt this. Well, the first thing is saving the service ticket, and then he will decrypt the encrypted part of the TGS response with the mutual session key, the TGT associated session key, and will extract the other session key that is associated with the Thieves service ticket. So now the service can access the shared folder by creating another authenticator with the new session key, the mutual session key, and sending the service ticket for Thieves and that authenticator. You can see here the service ticket and the authenticator in the name of Vegeta. And finally, the SQL01 will decrypt this service ticket with his own secret key, will extract the session key, will decrypt the authenticator, will confirm the ownership of the ticket and the authenticator, and then the service will allow Web01 to list the contents of the shared folder. So as a final move, there is this AP response, a mutual authentication, where the SQL01 service encrypts a timestamp with the mutual session key between these two services and sends it back to Web01. We can see here this is the decrypted. We can see the date and the hour. This is the timestamp. Okay, So Web01 just decrypts this information to confirm that the SQL01 is the legitimate SQL01, and Web01 does the same with the client. He encrypts a timestamp with the shared session key, which is the gray one, and sends it back to the client. Again, we can see here the date and the hour, the timestamp, and the client uses a mutual session key to decrypt and confirm that the server browser service is the legitimate one, because he holds the session key as well as we do. Okay. So as we can see, these are all the steps performed by unconstrained delegation. First the TGT, then the service ticket, a regular service ticket for HTTP. Well, it's not a regular because it has the OK as delegate flag. So we as the client, when we see that flag, we respond with a second TGS request asking for a delegation TGT. The KDC expects this second request and responds with a forwarded TGT. We can use all the information to authenticate into the service, sending the HTTP service ticket, and the authenticator where the delegation TGT and associated session key will be stored. And when the service obtains that delegation TGT and session key, he can use both of them to act on behalf of Vegeta and ask for a thief's ticket. This thief's ticket, he can use it for accessing the served folder, to list the contents, and then to respond back to the client with all this information and a mutual authentication. Okay. So in order to abuse unconstrained delegation, it is quite straightforward, because we know every client will drop his TGT and session keys when he interacts with the service, the unconstrained service. So if you happen to compromise one of these servers or one of these services, you will be able to dump or to extract all the session keys, all the TGTs of every client that connects to the service. Okay, so you should know that the common ways of abusing this are two. So you can just wait for clients to connect to the service and dump their TGTs, or you can try to force hopefully privileged principals to connect to the service, either by phishing someone and making him to connect to the service, or by using things like RPC calls or functions offered by other services. An example of RPC calls is MS-RPRN, which is the spooler protocol, where you can ask a spooler to connect to your server. The server, the computer that is where this spooler service is running on, will authenticate into your unconstrained service and will drop his TGT, and you will be able to use it to impersonate that computer or that service account. Okay. Another example could be XP-dir3 for a SQL server that is running with a network service account or a domain service account, and it will authenticate into your unconstrained service, and you will be able to extract everything. So as a proof of concept example, we see here how administrator connects to the web application to servebrowser.capsule.core. So if we verify, if we compromise Web 01, which we know it's the host that is offering this web application, we can see the TGT of administrator and the service ticket for thieves. Again, property of administrator. So we can just extract this information and act as if we were administrator. We can impersonate administrator. Another example which requires us to change a bit of the configuration of the web application, because in this case the web application is configured to run with a domain service account, which we remember is the servebrowser service domain account. Okay, so that account is configured with unconstrained delegation, but only that account. So if you try to access any other service of Web 01, those services are not configured with unconstrained delegation. It is only configured the web application. Okay, but if we change that that configuration, and instead of using the domain service account, we use the computer account, this is Web 01 $, okay, then all the services offered by Web 01 will be configured with unconstrained delegation. So in that case, we can use things like the spooler technique so as to force another host, for example, the domain controller, to connect to our Web 01 service. We can see that indeed the domain controller connected to our Web 01 service, and he dropped his own TGT. If we have the TGT of a domain controller, we can impersonate a domain controller. And domain controllers have replication privileges, so we can use that to run a DZ-Sync attack. For other regular computers, if we happen to obtain a TGT from them, a good technique for compromising them is combining unconstrained delegation with resource-based constrained delegation. But obviously you will need to understand how RBCD works before understanding how to mix these things in the same attack. So these are interesting links about the subject. I really recommend you taking a look at them. This one, we see how Harmjoy, Will Schroeder, and Lee Christensen, if I recall correctly, they broke forest trusts by combining this unconstrained delegation thing with the spooler service of another forest. So they made that one domain controller from other forest connect to an unconstrained service that they had in the forest they compromised. The external domain controller dropped his own TGT, and they could abuse that to impersonate the domain controller and then compromise the other external trust. Dirkjan has a really nice post and really nice tools for abusing unconstrained delegation with relays and different stuff. And well, you have other articles really interesting to see about this subject. So that's pretty much it. In the next video, we will see how constrained delegation works. Thank you very much.